Yeah, good evening, class. So, today our topic is ellipse. The basic equation of ellipse we know is x square upon a square plus y square upon b square equals to 1. Parametric coordinates x equals to a cos theta, y equals to b sin theta. Here, theta is eccentric angle. Let's start with our first question. So, our first question is, if ax plus by equals to 1 and cx square plus dy square equals to 1 have only one solution, then see, this is a very general type of question. Here, what we have already learned in our previous classes is, if we are having these two equations and it is given that it has only one type of solution and only one solution, sorry, then what we can do is we can use the basic method of substitution, substitute the value of y from equation 1 to equation 2. So if we will substitute the value of y, we will get cx square plus d 1 minus ax upon b whole square equals to 1. So on simplifying, it will be cx square plus d 1 plus a square x square minus 2ax whole upon b square equals to 1. So you will get b square c x square plus d plus multiplying d with each term dA square x square minus 2a dx, and b square will be upon this equals to 1. So if we will take b square this side, so we will get this is equals to b square. On simplifying, our equation will be reduced to b square plus b square into c plus a square d into x square minus 2a dx plus d minus b square equals to 0. Now this is a quadratic equation, and if it is having only one solution, then the discriminant of this equation should be 0. So from the general quadratic equation, we know that if we are having a general quadratic equation ax square plus bx plus c equals to 0, and it is having only one solution, then that solution is x is equals to minus b upon 2a, and discriminant is 0. So on putting discriminant equal to 0, we will get one condition, and to find the value of x, we know that this is a suitable thing. So first of all, let's put discriminant equals to 0. Discriminant is b square minus 4ac equals to 0. On comparing, we are having b equals to minus 2ad, a equals to b square c plus a square d, and c equals to d minus b square. So our discriminant equals to 0 will lead us to this condition. In this, we have taken 4 common from both the sides. Multiply these terms, and on simplification, most of the terms will get cancelled out, and you will get only this condition: b square c plus a square d equals to cd. Now taking cd down, in the denominator we will get b square c upon cd plus a square d upon cd equals to 1. So our condition will be b square by d plus a square by c equals to 1. So this is our option 1 is correct. Let's move to see other options. The value of x, we have already seen x will be equals to minus b upon 2a. So in place of b, we are having minus 2ad, so it will be minus of minus 2ad upon 2. A is b square c plus a square d. Negative sign will get cancelled out, 2 will get cancelled out, and from here we already have b square c plus a square d equals to cd. From this equation, let's say this is equation number something 2, 1 we already have. So substituting this value, we will get x equals to AD upon CD. So x will be equals to A by C. So x equals to A by C is our option number B. Now let's find the value of y. So value of y can be found from this equation. Ax plus by equals to 1. So a x is A by C plus by equals to 1. So we will get y equals to 1 upon b 1 minus a square by c. Look, from the very initial condition, we are having b square by d equals to 1 minus a square by c. So substituting that value here, we will get y equals to 1 upon b into b square by d. So y will be equals to b by d. This gives us y equals to b upon d. This is not applicable here. So our options are A, B and C. In this type of question, what we have to do is try to find out as many relations as much you can. Now, moving to our next slide. Our next question is the equation of common tangent to the ellipse and the parabola are. So, when we'll go to the equation of tangent, we know that the equation of tangent is represented by t equals to 0. And to convert an equation to the equation of tangent, we replace x square by xx1, y square by yy. Here you can use the parametric coordinates also. If you are using the parametric coordinates for ellipse, then any point on the ellipse P is a cos theta comma b sin theta. Oh, sorry. Yes, b sin theta. So the equation of tangent at P will be given by, for the ellipse, let's write the ellipse x square upon a square plus y square upon b square equals to 1. Then that equation of tangent will be x into a cos theta upon a square, that will be x cos theta by a plus y sin theta by b equals to 1. So this is the equation of the tangent at any point P in the parametric form. So we are given the ellipse and we are also given the parabola. So this is for the ellipse, and for the parabola we already know that if we are having the equation of parabola y square equals to 4ax, then equation of tangent having slope m is given by y equals to mx plus a by m. So what we are doing here is we are finding the equation of tangent for this ellipse and we are finding the equation of tangent for the parabola. And since these two tangents are same, they are common tangents, so we will equate the two equations. So for ellipse, our equation will be x If you write it like x square by 2 root 2 whole square plus y square by root 2 whole square equals to 1, so that will be in this form x cos theta upon a. Here a is 2 root 2. So our equations will be for ellipse x cos theta by 2 root 2 plus y sin theta by root 2 equals to 1. And for parabola, since a equals to 1, so we are having equation y equals to mx plus 1 by m. So this is our equation of tangent to the ellipse, and this is our equation of tangent to the parabola. Now, writing this equation, putting this mx that side, so we will be getting, or we can say mx minus y equals to minus 1 by m. Now compare the coefficients of x both the sides. We will be having cos theta upon 2 root 2 upon m will be equals to, see if you are comparing the two equations, if we say a1x plus b1y equals to c1 and a2x plus c2y equals b2y plus equals to c2 represents the same equation, then you can compare the coefficients, that is a1 by a2 equals to b1 by b2 equals to c1 by c2. So likewise, on comparing, we will get cos theta upon m into 2 root 2 equals to minus sin theta upon root 2 equals to minus m. So from this we can find the value of cos theta. So cos theta will be equals to minus m square into 2 root 2 and sin theta will be equals to root 2m. Since we know that cos square theta plus sin square theta equals to 1, so substituting the value of cos theta and sin theta here, we will get a biquadratic in m. So our equation will be 8m to the power 4 plus 2m square equals to 1. On solving this equation, so you can solve this equation by 8m square plus 4m square minus 2m square minus 1 equals to 0. Taking 4m square common, we will be getting m square plus 1. Oh, sorry, 2m square plus 1 and minus 1 common, 2m square plus 1 equals to 0. So we will be getting 4m square equals to 1. This implies that m square equals to 1 by 4. So value of m will be 1 by 2 and minus 1 by 2. Substituting that value of m in this equation, because these two equations are representing the same equation and we are having the value of m, so we can write y equals to m, that is 1 by 2x plus 1 upon 1 by 2, or y equals to minus 1 by 2x plus 1 upon minus 1 by 2. From this we will get the two equations of tangent, and that will be represented by the 2 points, two forms a and c. So our answers are A and C. Let's move to our next question. So the next question is, the parametric angle theta of the point on the ellipse x square upon a square plus y square upon b square equals to 1, at which the tangent drawn cuts the intercept of minimum length on the coordinate axis. See if we are having an ellipse having center at origin and we have made a tangent. Let's say this tangent makes intercept of length a on x-axis and intercept of length, okay, a and b we already have, so let's say it's capital A and capital B. Then the equation of this tangent or this line will be x upon a plus y upon b equals to 1. And we are also given that it draws the tangent drawn cuts the intercept of minimum length. So length L will be equals to under the root a square plus b square. Simple Pythagoras theorem, or from the coordinates also you can find the distance formula. It will come out to be the same thing. So let's find the equation. Since it is given that parametric angle, so we will write the equation of tangent in the parametric form. So it will be x cos theta upon a plus y sin theta upon b equals to 1. But now here we can see that it is not in this form, so we will convert the equation in the intercept form. So it will be x upon a sec theta, because cos theta will be equals to 1 upon sec theta, plus y upon b cosec theta equals to 1. Now here a b we are having, on comparing you will get a equals to a sec theta and b equals to b cosec theta. Now the length L will be equals to under the root a square plus b square, that will be equals to a square sec square theta plus b square cosec square theta. We need to find the maximum, or we need to find the minimum value of L. So what we need to do here is, to find the minimum or the maximum value, we will apply the basic logic of AOD, that is maxima and minima. So from the basic logic of maxima and minima, we can see that if we will have the value of, find the value of L square first, L square will be equals to a square sec square theta plus b square cosec square theta. So this is the value of L square. We need to find the minimum value of L. To find the minimum value of L, we know that differentiation of L with respect to theta will be 0. So dl by d theta will be 0. Now differentiating, we will get a square same, sec square theta, differentiation will be 2 sec theta. For sec theta you will be getting, okay, I'm differentiating it here. So we are having L here, 2L into dl by d theta will be equals to a square. For sec square theta, differentiation will be 2 sec theta, and for sec theta we know the differentiation is sec theta into tan theta, plus b square as it is, and for cosec square theta it will be 2 cosec theta, and for cosec theta differentiation is minus cosec theta into cot theta. Changing all these terms into sine and cos, you will get differentiation equals to 2a square sine theta upon cos cube theta minus 2b square. And this will be, okay, I'm rewriting this quantity here. So since dl by d theta is 0, we will be getting 2a square sine theta upon cos cube theta minus 2b square cos theta upon sine cube theta equals to 0. So from this, taking this negative term that side, we will be having 2a square sine theta upon cos cube theta equals to 2b square cos theta upon sine cube theta. So 2 will get cancelled out. We will get 10 to the power 4 theta equals to b square by a square, that is 10 square theta equals to b by a. So tan theta will be equals to root b by a in plus or minus. Okay. So we will be having the different values of theta. First, theta will be equals to tan inverse root b by a, or theta equals to minus tan inverse root b by a, or. So from this, our option A is correct. Our option B is correct. And C is also correct because pi minus tan inverse root b by a will come out to be the value when you will use the basic inverse trigonometry. Moving on to our next question. Let A alpha and B beta be the extremities of the chord of the ellipse. If the slope of AB is equal to the slope of tangent at the point C theta on the ellipse, then the value of theta is. Now we can see that slope of AB we can find out if we are having an ellipse. Then alpha and beta are, we can say, the parametric angles. The coordinates of A will be A cos alpha comma B sin alpha, and the coordinates of point B will be A cos beta comma B sin beta. Now, if we are having the equation of ellipse x square by a square plus y square by b square equals to 1, and we need to find the slope of tangent at any point, then you are having the different methods. First method, you can differentiate it. On differentiating, you will get 2x upon a square plus 2y into dy by dx upon b square equals to 1. So dy by dx will be equals to minus x upon a square into b square by y. And in parametric form, when you will put x equals to a cos theta and y equals to b sin theta, so dy by dx will come out to be, that is the slope of tangent will come out to be minus b cos theta upon a sin theta. This is one method, or you can directly write the equation of tangent at this point x equals to a cos theta and y equals to b sin theta. So our equation will be x cos theta by a plus y sin theta by b equals to 1, and equating it by, and we know that for any linear equation ax plus by equals to c, our slope is minus a by b. So from this also you will get minus cos theta by a and on sin theta upon b. So these are the two methods you can find the slope. So just we have to find, it is given that a and b are the extremities if the slope of line AB. So for AB, slope will be from the formula 2-point form, that is b sine beta minus b sine alpha upon a cos beta minus a cos alpha. So that will be b sine beta minus sine alpha upon a cos beta minus cos alpha. This slope is equals to the slope of tangent. This one or this one, these both are same. So we have to just equate these two. Here we have applied the basic trigonometric property sine b minus sine a equals to 2 sine p minus a by 2 into cos p plus a by 2, and here cos b minus cos a is minus 2 sine b minus a by 2 into sine b plus a by 2. So on putting these two and dividing, we will get b will be cancelled out from b, a will be get cancelled out from a, and it will be minus cos alpha plus beta by 2 upon sine alpha plus beta by 2 equals to minus cos alpha by sine alpha. So negative sign will be again cancelled out, and we will get tan alpha plus beta by 2 equals to tan alpha. And we know that if we are having tan theta equals to tan something, say k, then theta equals to, general equation is k plus n pi. So theta can be this, or theta can be equals to this. So our options are A and C. Now moving to the next question, we are having the curve 4x minus 2y plus 1 whole square plus 9, 2x plus y plus 2 whole square equals to 25 represents itself as an ellipse. Then we need to find the center of the ellipse and the eccentricity. So for these conditions, if you are having any condition of ellipse like say a a1x plus b1y plus c1 whole square plus b a2x plus b2y plus c2 whole square equals to, let's say, some c square, then first we have to convert this equation into the standard form. And how we will convert this equation into standard form is, step 1, a1x plus b1y plus c1 whole square, we need to divide it by under the root a1 square plus b1 square. So when you are multiplying dividing it, you need to multiply it, but you are having a square sign, so root sign will cancel out and it will be a1 square plus b1 square. Similarly for b, a2 square plus b2 square, and it will be a2x plus b2y plus c2 upon under the root of a2 square plus b2 square whole square equals to c square. Now we will replace this whole quantity by some capital X, and we'll replace this whole quantity by capital Y. So we will be getting x square upon a1 square plus y square upon b1 square equals to 1. This c square will come here in divide sign, and we can see that if we'll compare, so you are having x equals to this quantity, y equals to this quantity, a1 square is your c square upon a1 square plus b1 square, and b1 square is your c square upon b a2 square plus b2 square. Now the eccentricity of this ellipse will be same as the eccentricity of this ellipse. For the center of ellipse, to find center of ellipse, the concept is you need to find point of intersection of lines a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. So this is our concept here. Now we would be applying the same concept. So here a1 is 1, a2 b1 is 2. So we will divide and multiply by under the root 5 here, under the root 5 here, and we will have 5 outside. So 5, 5 and 5 will get cancelled out. So we will be having x square upon 5 by 4 plus y square upon 5 by 9 equals to 1. So this will be a reduced equation of ellipse. And now if you see the reduced equation of ellipse, we know the eccentricity is under the root 1 minus b square by a square. So that will be under the root 1 minus 5 by 9 divided by 5 by 4. So we'll be getting under the root 1 minus 4 by 9, that will be under the root 5 by 9, that is root 5 by 3. So our eccentricity is root 5 by 3. Now on solving these two equations, x minus 2y plus 1 equals to 0 and 2x plus y plus 2 equals to 0, we will get the coordinates of center. Multiply the first equation by 2, multiply the second equation by 2, so you will be getting 4x plus 2y plus 4 equals to 0. Add these two, you will be getting 5x plus 5 equals to 0, that is x equals to minus 1. So x will be equals to minus 1, so y will be equals to 0. Put x equals to minus 1 here, y will be equals to 0. Or what you can do is, you can go for the by options. You are having these two equations, check. 0 comma 0 is not satisfying both the equations, so it is not the center. Minus 1 comma 0, minus 1 plus minus 0 plus 1, so it will be 0, and minus 2 plus 0 plus 2, it will be 0, so this is satisfying. So it is our center of ellipse. And eccentricity we have calculated, although these two are written same. So our option is this, or say this. Moving to our next question. So our next question says, the tangent to the ellipse is cut by the tangent at the extremities of the major axis at t and t dash of the circle on t dash as a diameter passes through the point, then q may be. So we are having this ellipse here, a is square or a is greater than b, so our major axis is x-axis and minor axis is y-axis. It is given that the tangent to the ellipse is cut by the tangent at the extremities. So at extremities, the equation of tangent will be x equals to 3 and x equals to minus 3. At these 2 points, let's say we are having this tangent. So the 2 points are t and t dash. Now we are having a circle with t dash as a diameter. So it is asked that the circle will pass through the point. So let's find the equation of circle first. For this, the equation of tangent will be here a equals to 3, b equals to 2. So our equation of tangent in the parametric form will be, let's say this is point p something. So equation at this point, a cos theta and b sin theta point P is a cos theta comma B sin theta. That is 3 cos theta comma 2 sin theta. So equation of tangent will be x into 3 cos theta by 9 plus y into 2 sin theta by 4 equals to 1. So we will be having x cos theta by 3 plus y sin theta by 2 equals to 1. Now here, to find the coordinates of point T, we already know that x equals to 3. So we just need to find the y coordinate, substituting value of x equals to 3. So y will be equals to y sin theta by 2 will be equals to 1 minus cos theta, because 3 and 3 will get cancelled out. So we will be getting y equals to 2 1 minus cos theta by sin theta. So this is for t. For t dash x equals to minus 3, so that will be plus, so y will be equals to 2 into 1 plus cos theta by sin theta. So we are having the coordinates 3 comma 2 1 minus cos theta by sin theta, and minus 3 comma 2 1 plus cos theta by sin theta. Now overall, if t dash is acting as a diameter, then we know that if we are having the endpoints of diameter as x1 y1 and x2 y2, then equation of circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Here we are having x1 y1 x2 y2. So if you will put these points and find the equation of circle, then you will get x square plus y square minus 4 cosec theta into y minus 5 equals to 0. Or you can find the equation, or like this also, you are having the end points x1 y1 and x2 y2. So the center will be x1 plus x2 y2 and y1 plus y2 by 2. So you can find the coordinates of the center of the circle, and you can even calculate the radius by distance formula. This is the second method, and this is our method 1. So you are having both the methods. Now, if you see this thing, then we need to find the circle will pass through this point Q. We can see by options minus root 5 comma 0 will satisfy it, because minus root 5 square will be 5, 5 minus 5 will be 0, and y is already 0. Secondly, B also satisfies it. So A and B are our options. C does not satisfy it. On putting x equals to 0 and y equals to 0, our equation is not satisfied. Now for point D, on putting x equals to 3 and y equals to 2, again our equation is not satisfied. Moving on to next question. If the tangent to the ellipse at the point p theta is normal to this circle, then theta equals to. See, the level of these questions is not difficult. Actually, they are having multiple concepts which can be used in the various exams. So we are given, if the tangent to the ellipse x square plus 4y square equals to 16 at a point p theta is normal to this circle. So we can easily find the equation of tangent at this point. For the equation of tangent, we will be having x square upon 16 plus y square by 4 equals to 1. So our coordinates of P point will be 4 cos theta comma 2 sin theta. So equation of tangent will be x into xx1 plus upon plus yy1. We have to replace x square by xx1 and y square by yy1. So our equation will be x cos theta plus 2y sin theta equals to 4. Now it is given that this equation is normal to this circle. Okay, if we are having a normal to the circle, then we know that normal to the circle will pass through the center of the circle. So from the general equation of circle, we can find its coordinates of center, that is 4 comma 2. If we are having the equation of circle x square plus y square plus 2gx plus 2fy plus c equals to 0, then the coordinates of center are minus g comma minus f, and radius is under the root g square plus f square minus c. So it will pass through this point. So we will be having 4 cos theta plus 4 sin theta equals to 1. Oh, sorry, 4. So we will be having cos theta plus sin theta equals to 1. Now, either you can solve it or you can go it by options. Pi by 3 is pi by 3 satisfying it. Cos pi by 3, 1 by 2, sin pi by 3, root 3 by 2. Its sum is not equals to 1. So A is not the correct answer. B, pi by 2. Cos pi by 2 is 0. Sin pi by 2 is 1. 0 plus 1 is 1. So B is our correct option. C, cos 0 is 1. Sin 0 is 0. So 1 plus 0 again 1. So C is our correct option. D, minus pi by 4. Cos minus pi by 4 will be equals to 1 by root 2, and sin minus pi by 4 will be equals to minus 1 by root 2. So our LHS will be 0 and RHS is 1. So this is not satisfying. So our options are B and C. Now, moving to our next question. So our next question is, if P is the point on the ellipse x square by a square plus y square by b square equals to 1, whose foci are S and S dash, let the angle PSS dash equals to alpha and PS dash S equals to beta. Then see if we are having an ellipse for which A is greater than B and we are having any point P. This is our focus S dash. So PS plus PS dash is equals to 2A if A is greater than B. And in case B is greater than A, then our ellipse will be of this shape. So S dash will be here. So PS plus PS dash equals to 2B. Because this is the basic definition of the ellipse. Ellipse is defined as a locus of a point. Ellipse is defined as a locus of a point which moves such that the sum of its distances from the two fixed points is always constant, and those two fixed points are the foci, and that constant distance is equals to that sum, that which is constant, is equals to the length of the major axis. When A is greater than B, then the major axis length is 2A, and when B is greater than A, then major axis is y axis and its length is 2B. So here we can see option A is correct and option B is correct. Now, moving for the option C or moving for the option D, we can see if we are having this point P, this angle, well, let's make something like This angle here is alpha and this angle here it is beta. So if you'll see, this length will be Ps cos alpha and this length here it will be Ps dash cos beta. So you are actually having Ps cos alpha plus Ps dash cos beta is the length between the two foci. So it will be equals to 2a. 2ae. Now, similarly, Ps cos alpha plus Ps dash cos beta equals to 2ae and Ps sin alpha will be equals to Ps dash sin beta. So from these two, and we are having plus Ps dash equals to 2a. On solving these equations, we will get the value of Ps and Ps dash. See here, Ps is sin alpha is equals to Ps dash sin beta. Okay, so you will get the value of Ps and Ps dash. Now, substituting these two values in 3, so you will be getting 2ae sin beta by sin alpha plus beta plus 2ae sin alpha by sin alpha plus beta equals to 2a. 2a will be cancelled out. E sin beta plus sin alpha will be equals to sin alpha plus beta. Now, E sin c plus sin d, that will be 2 sin c plus d by 2 into cos c minus d by 2, and from the formula of sin 2 theta it will be 2 sin alpha plus beta by 2 into cos alpha plus beta by 2. So these two terms will be cancelled out and we will be getting E into cos beta minus alpha by 2 equals to cos beta plus alpha by 2. Using the basic trigonometry, you will get the value of E, which will be equals to cos beta plus alpha by 2 upon cos beta minus alpha by 2. Then use componendo and dividendo. So you will get this value. So we will be having option C, correct option. And now, going for this values, we can see that option D is not our correct option because in option D, tan alpha and tan beta it is required to find out. And if we'll put the values of eccentricity we know it is equals to under the root 1 minus b square by a square. So we'll substitute this value. You will not get the result as the option D. So this is not our correct option. Now, moving to our next question. If the chord through the point whose eccentric angles are theta and alpha on the ellipse passes through the focus. See, in the previous question also, we were having these 2 points whose eccentric angles were alpha, beta, and we were having this relation. So we can say that this is a generalized relation. So if the foci are, if these two passes through the foci A comma E, so we can write the result directly that if theta and phi are eccentric angles of point which passes through focus AE comma 0, then tan theta by 2 into tan phi by 2 will be equals to E minus 1 upon E plus 1. Similarly, if theta and phi are eccentric angles of point which passes through focus minus A comma 0, then we will be having tan theta by 2 into tan phi by 2 equals to E plus 1 upon E minus 1. These two results are very important. So we are not given that which foci it is passing, so this may be this foci or this foci, so we can have the two options, that is A and B. So our correct options are A and B. Moving on to next question. If x minus 2y plus 4 equals to 0 is common tangent to the parabola and the ellipse, then the value of b and the other common tangent are given by. So the equation of tangent in slope form for ellipse, our equation is y equals to mx plus minus under the root a square m square plus b square. For parabola, y equals to mx plus a by m. Since this is a common tangent, so let's rewrite it in this form. So we will be getting y equals to 1 by 2x plus 2. Now when you will compare it, you will get m equals to 1 by 2 here. 2 equals to plus minus under the root, or we can say that 2 is equals to under the root a square m square. A square is 4 and b square is our not given, so we need to find it. So that will be 4m square plus b square. So that will be 4 equals to 4m square plus b square. See, we have compared this c with this c. And parabola, let's write it capital A. You won't get confused in this. Then m is also given 1 by 2. So 4 will be equals to 4 into 1 by 4 plus b square. So b square will come out to be 3. So b will be equals to plus minus root 3. Now we need to find the equation of other tangent. Since we are having m equals 1 by 2. Now we can see here for the parabola, equation will be here a equals to 1. So for the parabola, the equation of tangent will be y equals to mx plus 1 by m, and for ellipse we are already having y equals to mx plus minus under the root a square m square plus b square. These two quantities should also be compared, so these two quantities should be same. So we will be having 1 upon m square will be equals to, on squaring these two quantities, a square m square plus b square. So 1 upon m square will be equals to 1 by 4, 4 into 1 by 4 plus b square, and b square we were having 3. So 1 upon m square will be 4. So m square will be 1 by 4. This implies that m will be equals to minus 1 by 2. Now putting the value of m equals to minus 1 by 2 in this equation, we will be having y equals to minus 1 by 2x minus of minus 1 by 2. So that will be 2. So our equation will be 2y equals to minus x minus 2. So the correct options are A and B. B can have two values, root 3 and minus root 3, when B equals to root 3 and the other tangent is x plus 2y plus 2 equals to 0, plus, sorry, 4 equals to 0, this 2 will get the side. Okay. Now moving on to our next question. On the ellipse, the point at which the tangents are parallel to this line. So we can see that the slope of this line is 9 by 8. And we need to find the point on the ellipse for which the slope of the tangent is 9 by 8. If you are taking the general points x1, y1 also, then the equation of tangent will be 4x x1 plus 9y y1 will be equals to 1. And since here the slope will be equals to from minus a upon b, that is this formula ax plus by equals to c, the slope is minus a by b, so it will be minus 4x1 upon 9y1. So comparing these two, minus 4x1 upon 9y1 will be equals to 9 by 8. We will be getting oh sorry, here the slope is 8 by 9 as y equals to mx plus c4. So that will be 8 by 9. So 9 will get cancelled out, this will be cancelled out 2, so x1 will be equals to minus 2y1. Put this equation directly, so this point x1 y1 is lying on the ellipse, so it will satisfy the equation of ellipse. So 4x1 square plus 9 y1 square equals to 1, and x1 is this, so 16 y1 square plus 9 y1 square equals to 1. So we will be getting y1 square equals to 1 by 25. This implies that y1 equals to plus minus 1 by 5. From this we can find the value of x1. Put y1 equals to 1 by 5, x1 will be equals to minus 2 by 5 when y1 is 1 by 5, and when y1 is minus 1 by 5, then we will get x1 equals to plus 2 by 5. So our correct options are B and D. Moving on to our next question. In a triangle ABC with the fixed base BC, the vertex A moves such that cos A plus cos C is equals to 4 times of sine square A by 2. If ABC denotes the length of the sides of the triangle opposite to the angles AB and C respectively, then see, we are having cos A plus cos C or cos B plus cos C, so it will be 2 cos B plus C by 2 into cos B minus C by 2. It will equals to 4 sine square A by 2. Now we can see b plus c by 2 is equals to pi by 2 minus a by 2, since a, b, c are the angles of the triangle. So sum a plus b plus c will be pi. So a by 2 plus b by 2 plus c by 2 will be pi by 2. So from this we will be getting 2 sine a by 2. Why? Because cos pi by 2 minus theta is sine theta into cos b minus c by 2 equals to 4 sine square a by 2. So sine a by 2 and sine will be cancelled, 2 will be cancelled to 2. We'll be getting cos b minus c by 2 equals to 2 sine a by 2. Now if you will see here, then the problem we are facing is we do not have that relation in the half angles. If we were having the sine A, sine B, sine C, then we know that sine A upon A equals to sine B upon B equals to sine C upon C. So I'm trying to convert it into that form. So I know that if we are having 2 sine A by 2, then we have to multiply both sides by cos A by 2, because sine A by 2 sine A by 2 into cos A by 2 will be sine A. So we'll be getting cos B minus C by 2 into cos A by 2 is equals to 2 sine A by 2 into cos A by 2. Here it will be sine A. And now for A by 2, we know that A by 2 will be equals to pi by 2 minus B plus C by 2. So again, cos A by 2 will be cos pi by 2 minus B plus C by 2, and cos pi by 2 minus theta is sin theta. So we will be getting sin B plus C by 2 into cos B minus C by 2. And we know that if we multiply 2 both sides, then this value is sin B plus sin C equals to 2 sin A. From the relation sin A upon sin formula or Lami's theorem, sin A upon A equals to sin B upon B equals to sin C upon C. So we can see that B plus C will be equals to 2A. You can put it equals to K. So sin B will be KB, sin C will be KC, and sin A will be KA, and K will get cancelled out. So you will get B plus C equals to 2A. So this is our correct option. And secondly, we can see that sum of the two distances from a fixed point is always a constant. So we are having 2A equals to constant. So we can see that B and C are our two foci, and vertex A lies on the ellipse. So C is also the correct option. Okay, we don't need to solve this. Okay.